And it is that time. We are about to get started here on the filming for the 2023 AMC 10A Problem 1. It was also the 12A Problem 1. If you'd like my predictions about Amy Floor and stuff like that, I will do that in a separate video. For now, I just want to get started. I'll talk about how easy or difficult it was in that video as well. Let's get to, you can look for it on my channel. It'll be separate from the other content. Cities A and B are 45 miles apart. Alicia lives in A and Beth lives in B. So you've got some segment, you've got A, you've got B, you've got 45. A with A, B with B. Makes sense. Alicia bikes towards B at 18 miles per hour. So 18 miles per hour. And Beth leaves at the same time biking towards A at 12 miles per hour. So she's going 3 miles for every 2 miles she's going, right? Because every unit of time, 1.5 times more distance than her. So that would mean that they're going to cut the distance in a 3x to 2x ratio. So how many miles from city A will they be when they meet? So the distances each will travel will be this, and you're just going to sum those up and set it equal to 45, and x is 9 and 3x is 27, and that's what A went. So the answer is E. Let's go ahead and get to problem 2. And continuing on with the 2023 AMC 10A problem 2, also the 12A problem 2. The first 3 questions on both tests are actually exactly the same. The weight of 1/3 of a large pizza. So together with the weight, okay, 3.5 cups. So you're gonna have to start writing some equations. Get started quickly. The first 5 questions are usually about speed as much as possible. So you're gonna put 1/3 of P, P is the pizza, together with 3.5. Let's make it 7 halves. Nobody likes mixed numbers. Maybe they do sometimes, but not right now. Equals is the same as the weight of, so we're doing weight, not cost. Keep track of those details as well. We're going to have 3/4 of the pizza plus 1/2 of a cup of orange slices. A cup of orange slices weighs 1/4 of a pound. Pause here before you plug in 1/4 and make sure it's what you want. What was the C representing? It's representing 1 cup. So if we have 3.5, you have 7 halves times the weight of 1 cup. That's exactly what we do, is plug it in. Plug it in your mind is better. You're going to get 7/8, and here you're going to get 1/8. That is bigger than that. What do we want to do? Probably solve for the pizza, right? What is the weight in pounds of a large pizza? So you're going to move this over here and this over here. 1/8 off of 7/8 is 6/8. So you're going to get 3/4 equals. This is going to be turned into 12ths. 4/12 of P and 9/12 of P. 4/12 off of 9/12 is 5/12 of P. Reciprocal multiply 12 over 5. 4 goes into 12 3 times. That's canceled. 3 times 3 is 9 over 5 equals P. 9 over 5 is 1 4/5. Let's get on to problem 3. Continuing right along with problem number 3 on both tests. How many positive perfect squares? Well, yeah, okay, perfect squares less than 2023. So immediately, perfect squares 2023, you should know the 5s rule, and you probably should know. I'll just go over the 5s trick for squaring things. If you're squaring a number that ends in 5, like any of these, all you're going to do is grab the non-5 digit, 1, and multiply it by the number that would come after 1 in a number line, 2. 25 gets added to the end. Same thing, 2 times the number after 2 in a number line, which is 2 times 3. So that's 6. Attach 25. 3 times 4, 12. Attach 25. 45 squared. Done it so many times, I just know instantly it's 2025. 4 times 5. So this is background for people who are experienced. They know a lot of these tricks. They've seen 45 squared. If you square 45, you get this. Immediately, you're looking for all perfect squares that are basically less than 45. They need to also be divisible by 5. To be divisible by 5, the base of the square is going to have to also be divisible by 5 because it's prime. That means you're doing 5 squared, 10 squared, all the way to where? We can't get to 45 squared. It's too big. So you're going to 40 squared. That's 8 times 5 and 1 times 5 starting from the beginning. You get A, 8. let's get to problem number 4. And the final problem of this rapid fire set, the 2023 10A problem 5. When I finished this problem, I was at 4 minutes and 32 seconds. So that gives you an idea. And I didn't even go as fast as I could. I slowed it down to make sure I'm not making mistakes. How many digits are in the base 10 representation? This problem is honestly fairly easy. All you're going to do is prime factor. So base 10, normal. So you're going to prime factor because you're looking for a bunch of zeros, because zeros are great because then they're just easy to count on the end. So they've had questions like this before. 2 to the 3rd to the 5th power is going to be 2 to the 15th. So 8 is 2 to the 3rd. When you see numbers, stop seeing the number 8. See it as all the things that it can be. 4 times 2, 3 squared minus 1, 2 to the 3rd, right? So 15, 3 to the 5th, 5 to the 5th, instantly. Okay, so 2 to the 15th times 5 to the 10th times 3 to the 5th times 5 to the 5th. That and that gives us 5 to the 15th with 2 to the 15th is 10 to the 15th. 3 to the 5th is 243. 243. Throw on 15 zeros. You might be uncomfortable with that. The answer is going to be 18. You might be uncomfortable solidly concluding that there's going to be 15 zeros or something. You can just test it like this. If you do 3 times 10 to the 1st, you get 3 with 1 0. If you do 3 times 10 squared, you get 300, which has the same number of zeros as the power of 10. So if you might have not done that in a while, give yourself little things like this to convince yourself that you're correct with that assumption. Most of you probably just made the assumption and moved on, but do be careful in case there had been a 19 here or something like that. Just make sure that you're checking these little conclusions if you're not used to making them. On to the next set of 5. And now for problem number 7 on the 2023 10A. It's also the last problem of the set of rapid fire for 12A problem 5. Janet rolls a 6-sided die 4 times and keeps a running total of the numbers she rolls. So 4 times. What is the probability that at some point her running total will equal 3? Well, if she rolls it 4 times, you're already going to be over 3, so we really don't care how many times she's going to roll it. Maybe that's just there like extraneous information, so you stop to consider it, but there's really no need for it. We know that she has at least enough rolls to get to 3. So we just kind of want to list out every possibility. Don't forget it's a running total. So since it's a running total, let's write them all out. She could get a 1, fun 1. Those could be her rolls. That would add up to 3. She could get a 2 followed by a 1 or a 1 followed by a 2. And finally, she could get just a straight up 3 on the first roll. So the chance of getting 1, 1, 1 is 1 out of 6 times 1 out of 6 times 1 out of 6. You're going to get 1 out of 216. And the 2 is going to be 1/6 times the 1/6 on the second roll is going to be a 1 in 36 chance, as will this also be 1 in 36, as will this also be 1 in 6. Not 1 in 36, there's only one roll here. So now we have to add all this up. So you're going to have 1 out of 216 plus. You have 2 out of 36, but I'm just going to multiply by 6. I don't want to reduce that. 1 over 18, that doesn't do us any good. So 2 out of 36 times 6 on the numerator and 6 on the denominator, because we know that 6 to the 3rd is 216. You should have your perfect cubes memorized. That's 12 over 216. Finally, you're going to multiply this by 36 over 36 to again get 216. So you'll have 36 over 216 there. 36 and 13 is 49 out of 216. There's no multiples of 7 there, so we're done. And let's go ahead and move on to problem 8, and we'll be right back.